I'm going to explain you Bayes theorem under probability. Probability. So under probability, we are going to discuss Bayes theorem. Bayes theorem. So as you all know, in your combined mathematics 1 paper in 17th A, so you will have a question from probability that is basically from Bayes theorem. So this video might be helpful for you to prepare for that question. Okay, so in this video what I am going to do is, first I will explain you what Bayes theorem is, and I will derive the equation for Bayes theorem using conditional probability. After that, I will explain you two questions using Bayes theorem. I will directly apply the equation, and then in another video, I will explain you the past paper questions with answers. Okay, so without further ado, let's begin. So let's assume, okay, I'm going to take two events A and B. I'm going to take two events A and B. Okay, right. So I have taken two events A and B. Right. So these two events are not occurring simultaneously. Let's assume event A occurs first and then B occurs second. Otherwise, B occurs first and then A occurs. Okay. So I'm going to take probability of A occurring when B has already occurred. So you might have studied under conditional probability. For this probability, the equation will be probability of A intersection B. Okay, it means probability of A and B divided by probability of B. So you put the probability of the event that is already occurred in the denominator. Right? So let me take this as the first equation, and in another example, or for instance, if B occurs first and then so this is that scenario. B occurs first and A occurs second. Now let's assume A occurs first and we have to find the probability of B occurring. So that is basically probability of B occurring when A has already occurred. So that is equal to probability of B intersection A divided by probability of A. Okay, right. Now let me take this as the second example. So I have written the conditional probabilities of these two events. So here B occurs first and then A occurs. Here A occurs first and then B occurs. Right. Now what I'm going to do is, I'm going to rewrite this equation. So making this portion as the subject. So basically, you know, this and this are similar, because let me take a Venn diagram. So this is event A and this is event B. So this is A and this is B. So this portion or this area represents A intersection B. That is equal to B intersection A. So the probability is here same, right? So with that idea, right? So probability of B intersection A should be equal to, I just multiply this with this. So probability of B occurring when A has already occurred into probability of A. Right. Now this equation is going to be substituted in this equation. So as I told you, probability of B and A is definitely equal to probability of A and B. So probability of B and E is equal to this one. So I can directly substitute that one. Probability of A occurring when B has already occurred is equal to probability of B occurring when A has already occurred into probability of A divided by probability of B. Now this is actually Bayes theorem. So the proof is coming from, this is the proof and this is Bayes theorem. Right? So proving this Bayes theorem is actually from conditional probability, and writing this equation is also very much important in the examination, right? So let's assume this means we have to find out the probability of probability of A occurring when B has already occurred. So B has already occurred and we have to find out the probability of A occurring. So this means, so we have name for this, right? So this is called posterior and this is called likelihood and this is called a prior, which means we have already done, and this is called marginalizer. So we have several terms for this, but that is not necessary for you. So these are from total probability. So this and this from total probability. You know what total probability is, right? So when I do a question, you will understand much on this. Right. Now I will explain you how to write this equation in the examination without any mistakes. So if you want to find out probability of A occurring when B has already occurred is equal to, right? Now you just interchange the positions. Probability of B occurring when A has already occurred. And in the numerator, you have to write the probability of the event that you are going to, that has occurred second, right? So into probability of A divided by probability of B. So this is very simple. B is in the if you consider this as a fraction, so this is in the numerator, you put the probability for that event in the numerator of the equation, and this is in the denominator, you put it in the probability of that event in the denominator. So this is how you have to write this equation, and with this idea I will move to the first question. So I will do only 2 questions in this video, and I will upload another video explaining the past paper question that has come so far. Right. Now I will take an interesting example, right? So let's assume there is a couple and the couple has 2 children. Okay. So the example 1, a couple has 2 children. Right. Now let's say a couple has 2 children, so they will have first child and second child. So they have 2 children. So what are the probabilities of having children sex-wise? So the first children might be a boy, and the second children might be, the second child might be a girl, and the first child might be a girl, and the second child might be a boy. Sometimes both children might be girls and both children might be boys. So these are the 4 possibilities of having 2 children for a couple. Right. Now a couple has 2 children. Now we have to find the probability of having 2 girls when they have at least 1 girl. Now this is total probability, right? So they can have these possibilities. But for this particular couple, they tell they have at least 1 girl. So this might be possible. 1 girl at least they have. This might be possible. Yeah, at least 1 girl. This might be possible. But this combination cannot be possible for this. We clearly know that this event or this scenario cannot be possible for this couple because they have at least 1 girl. So these 3 possibilities, they might have both children as girls. At least the first might be a girl and the second might be a boy, or else the first might be a boy and the second might be a girl. So this is the possibilities that this particular couple has. Right. Now this is coming under total probability. Right. Now I am going to directly write the equation for Bayes theorem. So find out the probability of having 2 girls provided that they have at least 1 girl. Right. Now this is the Bayes theorem, right? So I just read interchange the position of this. So probability of 1 girl when they have 2 girls, right? Into, so probability of 2 girls. So I write this here and I write this here, probability of 1 girl. Right. Now these 2 are coming from total probability. Right. Now tell me, what is the probability of having 1 girl when they have 2 girls? So let's say I have 2 girls. I have 2 children. and both are girls. So probability of having one girl is actually 1, right? You might think this is 0.5, but in this case, this is 1. So this is 1 into, right, probability of these two are total probability. So there are 4 possibilities. So out of these 4 possibilities, having 2 girls is 1, right? So this is this one. So 1 by 4. Right. Right. Now having one girl, at least one girl, but this is also total probability. So in the total probability, we have 4 possibilities, and out of these 4 possibilities, having at least one girl is this, and this. So there are 3. Right. 3 by 4. Right. Now if I simplify this one, 1 by 3 is the answer. So this means when the couple has at least one female child, okay, that is provided. The probability of having 2 girls when the couple has at least one girl is equal to 1 by 3. Yeah, that is true. So if you look at this one, this event cannot occur for this particular couple. So I eliminate this possibility from the total probability. So out of the 3 remaining possibilities, having 2 girls is 1 possibility. So this is the Bayes theorem. So hope you have understood this example. With that, I will explain another example. Now example number 2. Right. Now this example is going to be related to the equation that we have already studied, because I'm going to take 2 events, event A and event B. So event A, okay, so 2, 1, 2, 3, 4, 5 has the numbers 1, 2, 3, 4, 5. Okay, and event B has the events from 4, 5, 6, 7, 8, and 9. Okay. Now, what we have to find out is probability of A occurring when B has already occurred. Right? Now, this is what we have to find out. Now, the vice versa. Now, we tell the event A has already occurred and B is occurring second. Now, we have to find out the probability of A occurring when B has already occurred. So, the reverse conditional probability is going to be used here. So I can directly use the Bayes theorem. Probability of B occurring when A has already occurred into probability of A divided by probability of B. Okay, right. Now, let me consider this set. Okay, so this is event A and this is event B. Right? Now, these 4 and 5 are common for both events. So 4 and 5 is equal to probability of A intersection B is equal to 4, 5. Right. Now A has the elements 1, 2, 3, 4, 5, and B has the element 4, 5, 6, 7, 8, and 9. Right. Now I'm going to separately find out the probabilities of A and probabilities of B. So the sample size, the sample space contains 9 elements, and the event A contains 5 elements, and the event B contains 6 elements. 1, 2, 3, 4, 5, 6. So probability of A is actually total probability is equal to 5 over 5 divided by 9, and probability of B occurring is equal to 6 divided by 9. Okay, right. Now this means, okay, we have to find out this one, we have to know what this is, and we have found out this and this. So this means probability of B occurring when A has already occurred. Now I told you probability A has already occurred and B is already occurring second. So when A has already occurred, the probability of B occurring is this, right? So that is actually now A has already occurred. So how many B's are in A? So that is actually probability of B occurring while A has already occurred. So these two elements are in B and A. So these two elements are in A and B. So when A has already occurred, the probability of B occurring is out of the 5 elements in A, there are 2 elements in B. So that is basically 2 divided by 5. So I just substitute the values here. 2 divided by 5 into 5 divided by 9 divided by 6 divided by 9. So if I simplify this and will go this so 1 3 1 divided by 3. So what this means, right? So if I conceptually think probability of A occurring when B has already occurred is equal to 1 divided by 3. So let's assume B has already occurred. This has already occurred. And what is the probability of A occurring? So out of the 6 elements we have in B, there are 2 elements in A as well. So 2 divided by 6 is equal to 1 divided by 3. Right? So Bayes theorem works, and I hope you have understood how to derive the Bayes theorem equation and what is the applications of Bayes theorem. I have explained 2 examples here, and in another video I will try to upload the explanation of the past papers that we have in our A level final past paper. Thank you.